So tell you a little bit about our history, our results, and several cases and the results we obtained over time. To begin, I would like to talk a little bit about my history and Hypotech's history. I started working after my first training in Hypotech. Carly Marciu gave me the first opportunity in my professional career, and I had two challenges. The first was to implement ISO number one, and I had to standardize all documents, but also the development of this polyurethane with graphene. They had this project already designed since 2019, but I was the one who really made things work and started developing this project. In 2022, I was hired by the company, so that was sort of a continuation of my work. We had several cases already in the market, tests, and more than 150 tests in 2022. That year was very important for us because that's when we launched the product and we had all the analysis of the cases. In 2023, I graduated as an engineer at São Carlos University, and that's when we launched actually the product, not before that, 2024. And we had a lot of hurdles, but in the end, everything worked out, and we were able finally to launch the product. This year, with new challenges and a new opportunity, I started my master's in nanoscience and advanced materials, and we started to develop other materials using polyurethane and nanotechnology. I don't know if you know Empotech, but Empotech is a company that manufactures polyurethane parts, technical parts, wheels, profile cylinders, so different parts made from polyurethane. And we are based in Gaspar, Santa Catarina. These are some examples of our products. And Hypotech, from the very beginning, was concerned about quality assurance. Nossa. Ó, a gente já trocou e não tá dando certo não. Esse é o fone que tem que usar, ó.
Mas tava saindo ótimo ali.
Então, será que não foi algum problema? Peraí, deixa eu
Deve
tentar
ter
aqui,
sido.
será? E ver agora. And these are the customized solutions. So customers bring the problems to us, they present the problem to us, when we construct the solution together. From a technical standpoint, polyurethane, as you know, since you are in a PU expo, it's a very versatile PU. It can be a foam, an adhesive, and it can also be in rigid form, a TPU, a thermoset polymer, or elastomeric. In Hypotech, we supply this material. It is an industrial, very technical material with good properties regarding abrasion, and depending on the hardness, can be flexible or rigidity, depending on the requirement. So in 2019, we had this idea of using polyurethane with graphene and introducing this product into the market. And we had the support of Oxygraphene, a very important institution in this area, one of the most important manufacturers of graphene in industrial scale, and MWP. This company has been supporting us a lot since 2021 and helping us to make this launching come true. So just briefly, just to make sure we are on the same page, I think it's important to understand which are the properties that we were able to obtain. This demanded a lot of study, several tests, and I would like to begin by talking about graphene. We've talked about polyurethane, You all know what is graphene. You know where graphene comes from and when it was created. Is a recent nanometric material discovered not so long ago. And I like this image comparing the graphene sheet with a honeycomb. In nature, bees are the most intelligent animals, and they have this structure, which is one of the strongest structures that we have, the hexagonal ones. And I like to compare graphene with this structure, and that's how we explain graphene to our commercial personnel. Graphene is made of carbon atoms, so is diamond. But what is the difference between diamond and graphene? Graphene is nanometric, and diamond is the most rigid material we know. It has been the hardest one for years, but it's formed in different conditions compared to graphene. So we have the molecular chain, which is carbon, but the structure is different, and therefore the properties are different. Another thing I like to show is the origin of graphene. You know graphite, pencils, for example, so you all have used this. And graphite has a molecular structure that's very similar to graphene. And that's why technicians and specialists who have studied graphene used to work with graphite exfoliation, and this was the easiest way to obtain a graphene sheet in the lab. And this is very difficult. It's costly, and it requires specific equipment. And it's interesting to see how the graphite chains are formed. Several hexagonal structures combine or bound, and graphite is fluid and can be used even as a lubricant because of this bonding strength between different layers, which is weak. And that's why it can be easily exfoliated. And that led to the discovery of graphene. In these three images, can you tell me which one is graphene, the first, the second, or the third? Anyone? No guessing? The second. So basically, graphene is one graphite sheet. Just as a curiosity, think that this is just one section of graphite. The structures are long, but they have nanometric thickness. And carbon nanotubes are formed by a graphene sheet. However, it's tubular with different properties, such as much higher conduction, even though graphene is also a conductive material. And what is my purpose here? Is to tell you what are advantages of using graphene in our materials and why it's so studied. It's a very resistant material, but it's used in very small amounts. How can it increase resistance if it's used in small amounts? And we have come to understand this by testing and retesting. Graphene, as I said, is in a nanometric scale, is a very light material, the lightest one we have, and very flexible. As I said, the bonds between carbon atoms in an hexagonal structure are very strong. And when we pull from all sides, we can make it flexible, but it won't break due to these strong bonds. However, it still is flexible. So graphene has this flexibility property that can be added to materials depending on how it's processed. It's also conductive, but not as much as other materials. And in medicine, biocompatibility is being investigated. So which are the challenges? Why we don't have this in the market ever since we know graphene exists? That's because graphene requires a very highly qualified manufacturing, and in scale this is a problem. So we need to have reliable suppliers so that we can have good quality control. How can I perform my tests, which are very expensive, these microstructural tests, if I cannot trust that the graphene I'm getting from my supplier is a good one? Because graphite doesn't have the same properties as graphene, so we really must be careful, and we need tests, and empographin was something that was done in this manner with several different tests repeated again and again until we could determine which were the properties that we wanted to see in the market. And the tests are very expensive. That's why the material is expensive. Graphene is not only used because it's graphene. It has to be functional. It needs to have a structure that will help us to understand how molecules are bound, and this makes the product costly. And these are the major challenges that we see, and we could also think about further testing, etc. So we have this Olympicus running shoe, the Corre Grafeno, and it's one a good example because these products were also launched by Oxygraphene. They launched this a little bit before we launched our product, and it's a lightweight shoe with potential to improve performance because of the type of sole that includes graphene and other components in this shoe. More disruptive examples that we have, thinking about the ideology behind graphene, is foldable electronics and devices. This will be possible in the future. It's already possible in some labs, but this is an alternative for the medicine sector or industry where graphene is being used and studies are progressing. So let us talk about the reason why you're here today. You can use this QR code to access the video. So in 2023, empographene was introduced. It is an inert material, an elastomer, and it's protected by a patent. Since 2022, we have been really being careful with our patents, and we are also running for the prize here in FEFLA and FEFLU. And it's the first material that we have that is part of the PU nanotech line. And this will be our nanotechnology line with polyurethane. I will then give you our social network contacts so that you can follow us. Probably over the course of this year or the next year, we're going to have a new launch in nanotechnology. Graphene activated polyurethane. What could you do with these products? This product has enhanced properties, and I would like to explain to you how we discovered the chemical resistance. This hasn't been mapped at our first planning because graphene has barriers within the material. We started to map the properties that we wanted to test and which were the tests we would have to make or to do, and then all the formulations that we would need. We had more thermal resistance, more compression resistance, and more abrasion resistance, and even more interesting, it's antimicrobial. I don't know if you know what it means, but basically an antimicrobial material can prevent the growth of microorganisms and also the replication of these microorganisms. And they then will die over time. So it's not a bactericidal material, it just suppresses or inhibits the growth and replication of microorganisms. And we have data showing that bacteria counts dropped after being in contact with this material for 24 hours. So these two bacterial strains, the bacterial counts were reduced because of the contact with this product. So in packing plant, we have several equipment, a lot of equipment, I would say, and that can be in contact with food. So let's think of one case. This is one purpose, and the microorganisms are going to be in contact with this material, and they'll be contaminated. Several areas where the equipment will be used, and using this material can inhibit bacterial growth and replication. And this equals more biosecurity. These are some markets and examples. Part of our studies mapping, for example, hospitals, pharmaceutical industries, cosmetics and health, food and packing industry. This property, this antimicrobial property, is a benefit for all of these markets, and the product can then improve biosecurity or enhance biosecurity. Another important property is the resistance to abrasion, and this means longer durability for components, less maintenance, less need of replacement, and then a better cost-benefit relationship. Another very nice case are these kite profiles. And these three slots, we can think of cables that contain diamond to curved armor. So these are very high tension cables, and we have measured this comparing a material that can be found in the market and hypographene, empographene. So some parts with the manufacturer with empographene, and then comparing to materials available in the market, and then we compare the resistance to abrasion in both cases. So the difference is about 12-fold in terms of resistance to abrasion. And when we test this in labs, graphene really is better. But when it's used in the market, we can see clearly, combining all the properties, that we can really provide better properties, such as the use in guided profiles. I've already talked about chemical resistance. We hadn't mapped this property, but we have tested it because one of our customers had issues with chemical resistance because they manufacture batteries and they use sulfuric acid, and this would be on the floor and affect the wheels. And now, using our material, they are happy with the results they have obtained, and I will show you better in a video later on. So the wheels containing graphene do not degrade as quickly or as much, so they are more durable and more resistant compared to the common wheels you find in the market. In the company, we like to say that all chemicals have to be tested because they have different behaviors. So solvents, acids, they are totally different, and we need to test them. And in the Empotech lab, we can do all of these tests. And this is part of our budget and our project. And in this manner, we can obtain results. So material to ketone, which is commonly used in the industry, we have performed immersion tests, and we had good results in terms of chemical resistance. In this video, you can see the wheels on the left are a comparison between one of our wheels and a common wheel found in the market, and you can see the degradation caused by sulfuric acid. And the ones that contain graphene, they still are much longer last, so you can see that there are fissures, but they don't have craters and they don't have irregularities on the surfaces that are in contact with sulfuric acid. So this is a very interesting property. Other markets that we can operate in: fertilizers, petrochemical, mining, pharmaceutical, and all of these markets use a lot of chemicals. So these are industries in which our parts can be used and can be potentiated with the use of empographene. We also gain 20% resilience. How could we measure this? There is a permanent strain test, and this includes a test specimen with a specific measure, like height and width, and it is placed under compression for 3 days. And after this, we open the measuring equipment, and then we wait until the material regains its original form. When we measured our material comparing with materials found in the market and empographene, our material was already better than the one found in the market. We had 20% improvement, and as I've As I said, in the case of the wheels resistant to abrasion, in this case, we can have several improvements in durability of all parts, such as wheels, which is an easier example to give. So these are comparisons of different wheels used for different purposes, and the durability of the ones found in the market is the one the customer is familiar with. The average durability of Empotech, it's an average because it depends on how it's measured, the type of floor where it's used, and the operator, the load, and etc. But all of these cases were followed between 2021 to this day. And we have wheels such as this one with 7,300 hours is still used in a packing plant. So we have all the data from 2021, and the customer had never had a wheel that lasted so long. So it's a very interesting case of this synergy between graphene and the increasing of the thermal point, resistance to abrasion, and also compression. So the resilience of this material. Wheels are not flat, and they can be compressed with high loads. And after you remove the load, then the material will regain as much as possible its original shape. And finally, thermal resistance. We've tested this using temperature testing, TGA, and others to see what would be the thermal range that would lead to the degradation of this material. And almost 50 degrees of increase, that's what we obtain, and it's also an average, because these applications that use temperatures can be intermittent or continuous or all time during the whole working life of the part. We have to study this separately. So these are ranges for intermittent applications, but we can even increase this resistance. In reality, the part is able to withstand higher temperatures. And we also perform flammability tests to know more about this material. So we use 3 plates, and we apply direct fire on it, and then we determine how much volume had been lost. In all of these cases, due to the exposure to the flame, hypographene had less gripping than the other products, so the Empotech and the product commonly found in the market. In mining and other cases in other markets, it's important because fire is always a risk in these applications. And if this stripping would be too frequent, this degradation of the part, the fire can be much more difficult to control, and this is a safety issue for many of these industries. These are parts that we find in the market, the automotive parts, in factories, and they are exposed to high temperatures, and several parts are also used in ovens with high temperatures. And polyurethane is not known as a very thermal resistant material. It's not a type of plastic that has the most or the highest resistance to temperature, but with graphene and empographin, we can improve this property. And to conclude, this is a picture taken in 2021 when myself and Marcio were visiting empographin for the first time, and that's when we performed our first tests. And this led to a very good partnership. And since then, since 2023, we performed several studies using different nanotechnologies and other materials and nanoparticles that we want to introduce into the market, and soon I think we'll be able to launch them. These are our contact information, so if you want to get in touch with us, the company, or if you want to follow us on Instagram, if you have doubts and questions, I'd be happy to entertain you. Thank you.